We are now in section 10.2, which talks about a very important graph type, and that is the quadratic function, its translations and reflections. Reflections meaning flip, and translation means movement of the function on a coordinate grid. So we're talking again about a graphing concept. And we're saying, okay, it's on a coordinate grid. And a quadratic. Okay, so what the heck is a quadratic? Quadratic function is a polynomial. That means many terms with the largest exponent being x to the 2 squared. So, what does it look like, right? Well, it's called either a quadratic, because it's a square unit, or a parabola. A parabola. It's used most in engineering for satellites, for headlights, for how the slope of a ball being thrown against gravity makes a little U, an N really, or a U. So all of these things are important. So let's talk about the components of a quadratic. So we're saying f of x, a function, equals to some ax squared plus some bx plus a constant. All right, well, that's the structure of it. Now, it doesn't have to always have a bx or a c, but it has to have an x squared. A being some number that's attached to that x squared. And those are the parts we're going to talk about. Well, the general shape is like this. It's a U. And so we're going to first talk about this point. Now, the U can be like that or like this. This is a reflection. This is a standard form. All right. So this part right here can be either the lowest value or the highest value. And that's known as a vertex. Okay, so the vertex is the point where parabola stops and changes directions. Okay, so it's a pause. It's really more of a pause. And it's described circles, an HK, an HK. The value of H is the X value and K is the position on the function of the extent of that vertex. All right. So what else is the general shape? Well, it does have, sorry about that, it does have X and sometimes, should say sometimes for both, intercepts. If it has X intercepts, it can be 1 or 2 points. The Y is usually 1. All right. Well, what else does it have? Well, it has extremities, and well, let's talk first about the axis of symmetry. Because it does have this. That is when X equals a horizontal line at H. I mean, a vertical. I'm so sorry. That's why we mentioned that the vertex is an H and K. All right. So we're going to look at a parent function. A parent function basic, basic look. Right. So in this case, we know that y or f of x has to equal x squared. All right. So let's look at what this parabola looks like. So the first thing we want to do here is to construct a t-chart of ordered pairs. To graph the quadratic. All right, here we go. So let's start with x equals 0. Well, if f of 0 for x, then we have 0 squared, so we have 0. And that's our low point. So now we're going to do, let's do a negative 2. So f of negative 2 is a negative 2 squared. Well, any negative squared is a positive. Well, let's try its partner, 2. So we're doing f of 2, and that means 2 squared. And we notice the symmetry of this parabola. So we have the ordered pair 0, 0. Then we have negative 2 and 4, and 2 and 4. And we can see then that we have the parabola, the parent parabola. All right. Well, we said we had x equals 0 is the what? Axis of symmetry. And the vertex is 0, 0. And what can we say about this guy? So let's talk about that. Well, as we go from left to right, what is happening? Well, first off, it's decreasing till it reaches the vertex. Then it changes direction and increases to the vertex. Out of this without discussing domain and range. Domain is the values of x where the function can exist. Well, we know that the domain is negative infinity to infinity. Never has a start, never has an ending. It goes forever. Now, the range on this guy from the y value vertex, so we're talking from inclusive 0 to positive infinity, because it only exists above that 0 mark. It only exists there. All right. Well, I know that was a whirlwind, and I hope you take time to look at that in the video. You can pause it and make sure you make some notes. For some of you, it is a review. For others, you've been away from school a while, so you might want to revisit the information. So let's talk about the quadratic function. I mentioned this in the opening, that the function is ax squared plus bx plus c. And this is the vertex form of the quadratic formula. Now remember, we did the parent formula, right? So we know that y equals sum a x minus that 0 squared plus 0, because this is our hk, and our vertex for the parent was 0, 0. So if I do it, I have y equals ax squared, and that's all, because it's a 0. So you can see how all of this works out. Okay, so let's talk about our calculator. So we want to, let me turn that on. Sorry about that. Turn on my calculator. So isn't that crazy? Let me go like this. Where did it go? Right there. 2 minutes. All right, so let me here for you so we can all see it. Okay, so I was doing statistics. So what keys we're going to use, this is our home screen where we do all of our computations. We're going to hit the y equals, because everything on graphing is on the keys that are located below the home screen. All of these keys right here have to do with graphing. So we're going to hit that. Then we're going to remember that this key right here is negative. Second row, second key is the variable. So we want to enter our x variable, and then we do the x squared on it. And then we're going to do something interesting. We're going to hit the zoom key and hit 6, because I work with this all the time. Well, now let me come back over here and we can view what we did. So here is my parabola that we did by points, and here it is there. So we can hit trace, and it came out with 0, 0. Well, if I go this way and get to a 2, or close to it, right about there, I'm going to get the 4. Now, I'm not going to get an exact answer, but that's what it is. And if I go the opposite direction, I will get as close to a 4 as I can. Oops, too fast. And there it is. So that helps us. Now, the other thing we can do is go second calc value. And I can ask it for a -2 and enter, and it gives me that 4 that we got on the table. I can hit 0 and enter and get the vertex, 0, 0. I can hit 2 and enter and get the 4. The calculator that hopefully you've purchased either on your smartphone or in a handheld is very crucial in success. All right, so now we've learned that this is the vertex form. We've learned how to do that. And now we want to enter this guy right here. Okay, so we're going to use the graphing calculator to check our answer. All right, so here we go. Now I have it printed there to help me get squared away. So I'm going to go here. I'm going to leave my parent function so that we can see the transformation. And I'm going to enter the negative. Parentheses are above the number key, open parenthesis, and I'm going to hit my second row, go back. I didn't need that. I needed 3 minus the x squared. Oh, sorry, x. Oh, I'm making all kinds of mistakes today. Parenthesis, hit the x squared minus 2. All right. So I want to talk to you about this one first. So let me write it here. That's what I should have done so it had no issues. This part right here is called a vertical shift to the parent function. And here we have a change. So let's look at this graph. Now we know it's reflected. This is reflection. That means it's moved. And I have an 3 minus x. So that means that x is a positive 3 moved to the right and down 2. Graph to make sure. And this is how you would do it. You would do second calc value and do a 3. Now notice this. A 3 in the parent function, the blue graph, is a 9. Now if I flip down to the red, it is a -2. So we know that that is the vertex and it's flipped. All right. So what are we saying here? The graph of the -3 minus x squared minus 2 will be a graph of y equals x squared reflected over x-axis and shifted 2 units, 3 units to the right and down 2 units. All right. So what we're saying is what happened to the x first? It moved to the right 3 and down 2. All right. So here it has the graph of what we need. Well, we know it's not that one or that one or that one, so it is that one. All right. So there you have that. Okay. Now we're talking about graphs of a quadratic function with the following. If the parabola opens upward, then the a is greater than 0. Now remember, a is the coefficient, a number, in front of x squared. All right, so a is greater than 0. Now understand that if it is between 0 and 1, it stretches, and if it's greater than 1, then it shrinks. So here we go. And then it's going to tell us the y-intercept is x is 0, and the outcome of the function at x is 0. And the x-intercepts are f of x equals 0. In other words, we say 0 is equal to the quadratic. Because it's a quadratic, we should have two x-intercepts if it is possible. And the vertex, now this one's important because if it is in standard form, and that means that it is in y equals ax squared plus bx plus c, then we can use the numbers. To calculate the vertex without completing the square, without additional math work. In other words, to find the h, it is the opposite of b over twice a. And to find the k, it is f of the opposite of b over 2a. In other words, we find this first and then use it to find that. And we'll talk about the calculator as we go. All right, this has been a lot of basic form. So I'm going to stop right here, and then we'll start up at this position on part 2. Thank you for listening.